Okay, we're going to be testing the difference between proportions. This is from section 8.4, exercise number 13 from page 452 in your textbook. So, one thing you need to know about testing the difference between proportions is that there are no means involved. So, if you look at your little cheat sheet here, these are all proportions. Okay, your test statistic here will be a z. This is the data that you'll be entering into the calculator. If you needed to find critical values, you would use an inverse norm. This is how your hypotheses would show up. Um, okay, so this is from your textbook. I still expect that you will be reading the textbook to understand all the fine details of this process. Also, this is very similar to section 7.4 in your textbook. The difference here is that we have two proportions instead of one. So in exercise number 13, we have a little background information here, so let's take a look at that. It says, in exercises 13 through 18, use the figure which shows the percentages of newlyweds in the United States who have a spouse of a different race or ethnicity. The survey included random samples of 1,000 Asian newlyweds, 1,000 Hispanic newlyweds, 1,000 black newlyweds, and 1,000 white newlyweds. The survey was adopted, or this research was adopted from the Pew Research Center. Number 13 specifically states that at alpha level 0.05, so that's a significance of 5%, can you reject the claim that the proportions of newlywed Asians who have a spouse of a different race or ethnicity is the same as the proportion of newlywed Hispanics who have a spouse of a different race or ethnicity? So here's where our data is coming from. Okay, so it states here that the percentage of newlyweds who have a spouse of a different race or ethnicity. Okay, so for Asians, that's going to be 29% of the sample. Hispanics is going to be 27% of your sample. Blacks is going to be 18% of your sample. And whites will be 11% of your sample. Remember, we're dealing with proportions, so it's going to be some part of a whole, some part of the sample size. Okay? Now, here it states that at alpha level 0.05, can you reject the claim? So now they're going to tell us what the claim is. And the claim is that the proportion of newlywed Asians who have a spouse of a different race or ethnicity is the same as the proportion of newlywed Hispanics who have a spouse of a different race or ethnicity. Okay, so here, same as, that's a statement of equality, so that means that that's going to be our null hypothesis. So our claim is the null hypothesis, where we say that proportion 1 is equal to proportion 2. Okay? Now, we need to know what our N is. So N sub 1, okay, N for our first population. And again, our first population are the Asians, okay, and it's at 29%. Alrighty, so our sample size for this population is 1,000, and we know it's 1,000 because it's given to us up here in the start of the problem. Okay, so the sample size is 1,000. Okay, and our X value, okay, so that's the part of the whole population that we're referring to, is 29%. So 29% as a decimal is 0.29 times our sample size, which is 1,000, tells us that our X sub 1, which is the X from our first population, is 290. Okay. Our population size for our second proportion is given here, which is also 1,000. Now, will they always be the same? No, they will not always be the same. In this case, they are, though, so lucky us. Alrighty. And again, we can figure out our x for our second population by multiplying this percent by the total sample size, which is 270. So now, in this problem, we had to figure out what our x's are. In some problems, they will just give you x, okay? So remember that x is the numerator because our p is equal to x over n, and x is the numerator, which is the number of successes in the population, okay? Here we had to figure it out based on these percentages, and we know how to do that because if we have the sample size, we can multiply it by the decimal of the percent, and we come up with our number of successes here. Okay, so now we have all of our data for our first proportion and for our second proportion, and we can now go ahead and enter this into our calculator. So you're going to hit the stats button, okay, arrow over to tests, and select number 6, which is a 2 proportion z-test, okay? Now, in the calculator, you need to enter in this data as you see it here, okay? So you can either enter it in as a 290, 1,000, 270, 1,000, and then put in your alternative hypotheses there. Or you can let the calculator do the work, right? So you can enter in 0.29 times 1,000, press enter, and it'll still give you 290. Okay, your n is 1,000. Again, we have that data from up here. Your x sub 2 is 0.27 times 1,000, alrighty? And when you press enter, it'll turn into 270, so that's fine, that's what we want. Okay, and your n sub 2 is 1,000, and again, we're given that up here. Again, right here for your P1, that's always going to be your alternative hypotheses. And remember, the alternative hypotheses here is that P sub 1 is not equal to P sub 2. So we select the not equal to P sub 2 option, okay? So our P sub 1 is not equal to P sub 2. This row will always be the alternative hypotheses, okay? So after you get all this entered in, exactly the way you see it here or here, okay? Go ahead and press the calculate button. Alrighty. Now once you calculate this, you should have this data come back. So again, for your 2 proportion z-test, okay, our alternative hypotheses is that P sub 1 is not equal to P sub 2, okay, and we are given our test statistic here, alrighty, but this problem doesn't really call for this test statistic. If you needed it, it's right here, z will be your test statistic, but again, this problem doesn't really call for that, okay. This problem wants to know if we can support or if we need to support or reject the claim. So we're going to use the p-value for that, alrighty, and that's given to us right here. Before we get to that, to always double check that you entered everything in correctly, your p sub 1 should match this percent that we have here, okay, and your p sub 2 should match this percent that we have here, okay, and your n sub 1 and n sub 2 should match what's given, okay, which we also listed here. Alrighty, now looking at our p-value, and notice that our p-value does not have a hat, so that's how we know that that's the p-value instead of our other values, okay, our proportion values, alrighty? So that we're looking at the p that does not have the hat, alright, the one that's right up under your test statistic, and that is your p-value. So in this case, rounded to 4 decimal digits, our p-value is 0.3192. That is greater than our alpha, which is given up here, which is 0.05. So we fail to reject the null hypotheses. Remember, if p is greater than alpha, then you fail to reject the null hypotheses. So how do we interpret that? Well, our claim, okay, our claim was the null hypotheses, and we just failed to reject the null hypotheses, so we can use this interpretation here. Okay, so at the 5% significance level, there is not enough evidence to reject the claim. So this is your final answer. Yes, you have to do all of this to get to the final answer. You can also do this using your test statistic, but it's not really necessary because the calculator will give you the p-value, and your problem does not require you to use the test statistic. So the p-value is totally fine for this one. Alrighty? Now, Here's problem number 16. I want to see if you can take the information and the steps that we use from problem 13 to do 16, okay? Here are all your calculator keystrokes. Here's the answer that you should get. Make sure you try this yourself and get this answer yourself. If you have any questions or concerns regarding this email, be sure to contact me. You can send me an email, you can send me a remind message, you can ask me during office hours before or after class. Okay, thank you.